All right, we are ready for day 2 of elimination. And so we are going to do this first problem again in your spiral, and then we'll move into your toolkit. So this is 5.3, again, solving systems with elimination. This is the exploration from your textbook just to get us started. So work with a partner, and if you're in class, I really would love for you to turn to the person next to you and talk through this system. So feel free to pause the video and talk about this question. Can you eliminate a variable by adding or subtracting the equations as they are? If not, what do you need to do to one or both equations so that you can? Again, if you're in class with someone near you, pause this and talk about it for a minute or two. Okay, hopefully you discussed. So if I add these systems together, I am going to get 3x plus 6y equals 24. Nothing gets eliminated. If I subtract them, write it again. 2x minus x is x. Y minus 5y, that's a 1y, minus 5y is going to be negative 4y. 7 minus 17 is going to be negative 10. Again, nothing got eliminated. And again, that's the whole purpose of this approach. So just adding or subtracting isn't going to work. And then they give you a hint. What do you need to do to one or both equations so that you can? A common answer I've seen from different class members is to take this equation and divide it by 2. And I think the reason they're talking about that is so that you can have the same x here. So you can do that. You can divide everything by 2 if you take the 2x plus y equals 7. But what's going to happen? You're going to end up with x plus 1/2 y equals 7/2. Is that going to be very much fun to then add or subtract to your other equation? It's going to be subtraction because you'd have x's and x's. Is that going to be very much fun? No, not at all. So another common idea is instead of dividing, so let's break this up. This was dividing, is to go the other direction. What if we multiply? And we are going to, again, take these systems. And what I'm going to encourage you guys to do is to always set it up so that you are going to end with an addition problem. Remember, addition problems are when you have opposite signs. So look at these equations. What could I multiply this bottom equation by so that it has the same number of x's or y's, I suppose, as the top equation? And in this case, we could multiply the bottom by 2 so that they have the same number. So if I multiply everything by 2, then I'll end up with 2x plus 10y equals 34. But I just said that I want you to set it up so that you have to add. So we want the opposite sign. So what we're going to do, and it's not wrong if you just multiply by 2, is we're going to multiply both sides by negative 2. Notice I have those big parentheses around the whole left side because that has the x and the plus 5y. So I'm going to rewrite this top equation. This just comes over here. This comes over here. 2x plus y equals 7. And now this time I'm going to distribute that negative 2. So negative 2x minus 10y equals negative 34. You might be thinking, oh, there's a lot of negatives now, but it's going to, I think, be a lot easier if you set it up so that you can add. All right, now we can do this. 2x plus negative 2x is nothing. They cancel, they eliminate. Y, remember this is 1y, plus negative 10y. So 1 plus negative 10 is negative 9y. 7 plus negative 34 is negative 27. And then I can divide both sides by negative 9, and y will be 3. Now, I'm going to plug my y value of 3 into any of these 4 different versions. I guess it's only 3 different versions. We could plug it into this, we could plug it into this original equation, or we could plug it into this bigger equation. I always choose the equation that looks with the smallest numbers. So I'm going to do 2x plus 3 equals 7 and solve for x. So x would be 2, 3. Okay. Go ahead and get your foldable for today from your substitute. It's called Elimination with Multiplication. It looks almost exactly like the one the other day, but this time on the side here it says with multiplication. So if you want to take a second, tape that into your toolkit. It is the same lesson as yesterday, So it's still 5.3, solving systems with elimination. We're just adding kind of that next level of with multiplication. So we're going to fill in the front, and again, like we did on substitution, we're just going to set up the front. We're not going to solve, and then we'll solve on the inside. So sometimes you can just get away with this by only multiplying one equation by something. So the first thing I notice is the 10y and the 5y. I know that 5 goes into 10, so if I double this bottom equation, I can get the same number of y's. But I want to have opposite signs, so I'm going to multiply by -2 on both sides. I'm going to copy this top equation again, and then this is going to give me -8x minus 10y equals -10. And that way, I can add. In this case, y will be eliminated first. Let's look here and see how we could get rid of x first. So a common response is to take this top equation and multiply everything by 4 or -4. That way, I'll have 4x here, and then we can get the -4x on the top. So what we're going to do is another choice. Again, you'll notice these are the same equations, is multiply that by -4. That will give me -4x minus 40y equals -12. Then I stack that other equation, and now I can add them because I have a positive 4y and positive 4x and a negative 4x. And in this case, x will be eliminated first. Let's go ahead and solve the equations that look like this. So go to the inside of your little booklet, and we'll do those first. Those are on the top. So this is the problem we just looked at. Choose, I guess we should all do it together. I was going to say choose the one you like, but since I'm not there to walk you through it, we should all do it together. I'm going to do multiplying by the -4. So I'm going to rewrite this like we just did. And I'm going to go this way. So I'm going to have -4x minus 40y equals -12. And I'm going to stack my positive 4x plus 5y equals 5. And I'm going to add them. -4x plus 4x is nothing. -40 plus 5 is -35y. -12 plus 5 is -7. Okay, we're going to divide by -35. Now, this is where a lot of people make mistakes on this problem. The smaller number is in the numerator, so this means I'm going to have a fraction. I also have a negative over negative, so it's going to be positive. So 7 over 35, if you need to, then we can divide by 7 over 7, and that's going to give me 1/5. It's okay for you to get fractions. Now I'm going to plug this back into one of my original equations. I'm going to do the top one because it looks easier to me. 10 times 1/5 equals 3. X equals, if you need to, not x equals, sorry, x plus. If you need to do this as 10 over 1, that way you can do 10 over 5 equals 3. X plus 2, 10 divided by 5 is 2. Subtract 2. X equals 1. Again, ordered pair is your answer. Okay, now we're going to get into a word problem. The difference means subtract of 3 times the number x. So let's go ahead and do this. 3 times the number x. It says the difference of that and y, so that means minus y, is equal to -4. Okay. 2 times the number x plus 2 times the number y is equal to 72. All right, so there's our system. So I think it looks easier to take this top equation and multiply it so that I have the same or opposite number of y's. In that case, that means I'm going to multiply it by 2. So that's going to give me 6x minus 2y equals -8. I stack my 2x plus 2y equals 72 underneath it. They have opposite signs, -2 and positive 2y, so I'm going to add them. 6x plus 2x is 8x. Negative 8 plus 72 is going to be 64. Divide by 8. X equals 8. Again, go back to either equation and choose the one that looks easier to you. So I'm going to do 3 times 8 minus y equals negative 4. 24 minus y equals negative 4. Subtract 24. Negative y equals negative 28. Divide by negative 1. Divide by negative 1. Y equals 28. So because this is a word problem about x and y, we are going to write an ordered pair. For regular word problems that have labels, we don't write ordered pairs. Okay, let's go back to the front. Sometimes you can't just multiply one equation. Sometimes you actually have to multiply both equations. So if that's the case, what you're looking for is the least common multiple between the coefficients. So we're looking for the LCM of coefficients. So for example, I have a coefficient of 3 and a coefficient of 2. So the smallest thing that both 3 and 2 go into is 6. So you need to ask yourself, what can I multiply each equation by to get 6x's or negative 6x's? So in this case, let's multiply the top equation by 2. That will get me to 6x. Make sure you're showing it on both sides. And then I can do the bottom equation by negative 3. You can do by positive 3, but then you'd have to subtract your systems, and I'm trying to get you to set yourself up so that you're only adding systems. And again, our goal here is because we're trying to get them to have the same number of x's right now. So that would give me 6x minus 4y equals negative 14. And negative 6x, negative 3 times negative 5y is going to be plus 15y equals negative 30. And that will set you up because then you can add. That would get rid of the x's first. The other option is to try and get rid of the y's. So look here. I have 2 and 5. The smallest thing that 2 and 5 both go into is 10. So to get those to become 10y's, I can multiply that top equation by 5. And the bottom equation, I can either multiply by 2, and then I'll have negative 10y on both of them, or I can multiply by negative 2, and then I can have opposite signs. So 5 times 3x is 15x, minus 5 times 2y is 10y. Negative 7 times 5 is negative 35. All right, bottom one, negative 2 times 2x is negative 4x. Negative 2 times negative 5y is going to be plus 10y. See those opposite signs? And then 10 times negative 2 is negative 20. Okay, again, I can add. And then in this case, those y's would be eliminated. When we go to the inside, I think I'm going to do the bottom version, the 5 and the negative 2. So here we go. I'm going to multiply this by 5 and this by negative 2. And then I'm just going to copy what I had there. All right, I have opposite signs, so I'm going to add these together. Make sure you're putting that line underneath your systems and that you've got the plus sign in parentheses. 15 plus negative 4 is the same as 15 minus 4, so that's 11x equals, and it's equals because the negative 10y plus the 10y cancel out. Negative 35 plus negative 20. Again, if you need to go on the side here to help yourself, that's going to be negative 55. Divide by 11, x equals negative 5. Then I go back to one of my originals because the numbers are smaller. So let's do 2 times negative 5, the bottom one, minus 5y equals 10. Negative 10 minus 5y equals 10. Add 10 to both sides. Negative 5y equals 20. Divide by negative 5. Y equals negative 4. Ordered pair. Okay, word problem, your favorite. I'm going to do a smaller pen. Okay, So Nathan sells 5 cupcakes and 6 lollipops for $10.75, and Olivia sells 3 cupcakes and 4 lollipops for $6.75. How much do they cost? Okay, so let's start with defining our variables. Let C equal cost of cupcake in dollars. Let's do P for lollipop. P equal cost of, I don't want to do an L because it might look like a 1. You can use X and Y too if you wanted to. Okay, so let's write our equations. Nathan sells 5 cupcakes, so 5 times the number of cupcakes plus 6 lollipops for $10.75. Olivia sells 3 cupcakes and plus 4 lollipops for $6.75. Okay, neither of these have the same numbers of C's or P's. Personally, I want to look at my C's, just that's how my brain works. So I'm going to look at what's the smallest thing that both 5 and 3 go into, and that is 15. So, I'm going to multiply both sides. I'm going to multiply this by 3 and this by 3. I'm going to multiply this by 5. Actually, I'm going to make it negative 5 so that they're opposites, and negative 5. Okay, that brings me over here. You don't have to go to the right. That's just how my brain works. 3 times 5c is 15c, plus 3 times 6p is going to be 18p, equals, let's see, 10.75 times 3 is 32.25. You can just trust me on that. And then the negative 5 times 3c is negative 15c. See how they have opposite signs? Negative 5 times 4p is going to be minus 20p, equals 6.75 times negative 5 is going to be negative 33.75. Draw your line. These C's have opposite signs, which means I can add them. Okay, 15C plus negative 15C is nothing. That's why we did this. 18P plus negative 20P is going to be negative 2P. And then 32.25 plus negative 33.75 is going to be negative 1.5. Divide by negative 2, divide by negative 2, P equals, okay, a negative over negative is a positive. So half of 1.5 or half of 1.5, if you think about money, if you want to do it this way, half of $1.50 is 75 cents. And the reason I'm talking like that is because everything here was money. So that's going to be 0.75. That was P, and P was my lollipop. So it's 75 cents for a lollipop. I just spelled that wrong. Lollipop. Okay, now I have to go back and find my cupcake. So I like to go to the simplest one I can. I think that's the 5c plus 6 times 0.75 equals 10.75. Make sure you're just looking at the original part of your equation, just that part. Okay, so 5c plus 6 times 0.75 is 4.5. Subtract. Make sure your decimals line up. If you need to add a 0 there, go ahead. That's a common mistake. So now I can do 5 minus 0 is 5, 7 minus 5 is 2, 10 minus 4 is 6. That's why I jumped there. Divide by 5. C equals, that's going to be 1.25. And remember, we're dealing with money. So this is a dollar sign. Dollar sign always goes in the front. That's for a cupcake. So anytime you're dealing with systems, when you're having to write them from a word problem, you want to look at kind of the different chunks of information. So in this case, it was Nathan's situation and Olivia's situation. And like on your homework problem the other night about the elliptical, it was like the number of minutes that they wanted to spend exercising. So that was one equation. And then the calories burned was another equation. So you kind of need to look for different topics or themes, and that will help you figure out your 2 different equations.